Hi all the students. Today we are going to study a comparison of the OSI and the TCP/IP reference models. Now both the OSI and the TCP/IP reference models are based on the stack of independent protocols. By stack of independent protocols I mean that every layer has a separate or independent protocol for communication with its peer layers, right? In both the OSI and the TCP/IP reference model, the transport layer and the layers above it provide end-to-end services. You know, by end-to-end services, I mean that the senders and the receivers can directly communicate with each other without any help from the immediate neighbors. So they do not need immediate neighbors for communication. They can directly communicate. The sender on one host and the receiver on another host can directly communicate with each other, and such kind of services are known as your end-to-end services, and this is for transport layers and above it. That means transport layer and the layers above transport layer provide such independent services in case of both OSI and TCP/IP reference model. Now these are the similarities. You can clearly see this is the OSI reference model and this is the TCP/IP reference model. In the OSI reference model, I have 7 layers: the physical layer, data link layer, network layer, transport, session, presentation and application. And in the TCP/IP reference model, I have the host to network layer, internet layer, transport layer and application layer, right? I can see after the transport layer and between the transport layer and application layer there is a void between, because the need for the presentation and the session layer were not felt when this particular reference model, that is the TCP/IP reference model, was being designed, right? Now as I said, that transport layer and layers above, that is in case of the OSI reference model, I am talking about the transport layer, session layer, presentation layer and application layer. These are the end-to-end layers, or these are the layers that provide end-to-end services. And in case of the TCP/IP reference model, the transport layer and the application layer are the layers which are providing end-to-end services. So in both the cases, transport layer and the layers above are providing you end-to-end services. Now these were the similarities. We will focus here on the differences also. If I talk of the OSI reference model, the concepts which are important or central to an OSI reference model is the ability to clearly distinguish between the services, interfaces and protocols. Services, interfaces and protocols are key concepts of an OSI reference model. Also, it has been able to very clearly distinguish between these 3 concepts, right? Now, how does the OSI model make distinction between the services, interfaces and protocols? If I talk of services, what are services? Services are basically telling the layers that what the layer does and how, not how it does. That means a layer above will only know that what services it will be provided by the layer below it. But how that layer is providing those services, that this layer will not know. So basically services define the layer's semantics. Now if I talk of the interfaces, interface is a means of communication between the two layers, two layers in which the layer above sends the data and control information and the layer below sends the services to the layer above it. So the layer which is above would be sending data and control information to the layer below it, and the layer which is below would be sending its services to the layer above it through the interface. So this layer, the interface, basically what it is telling, it tells the layers above how to access the services of the layer below it. So this is the task of the interface. Now if I talk of the protocols, the protocols are basically used for communication between peer layers. So I can say that peer protocols are layers' own business. That means at each level what protocol each layer is using for communication. That is its own business, and it can independently decide which protocol it will be using for communication. At the same time, at any point of time, these protocols can be changed by the layers independently, as long as its job is getting done and it is able to provide services to the layers above it, it is okay. So these are the three ways in which a clear distinction is made between services, interfaces, and protocols. Services tell what the layer does and not how it does. Interfaces tell the layers that how they can access the services of the layers below them. And protocols, the layers itself will decide what protocols it will use for communication, and if it wants to change those protocols, that also it can do on its own independently. The only concern is that the job should be done, right? Now, if I talk of the TCP/IP reference model, the TCP/IP reference model did not originally distinguish between the services, interfaces, and protocols. So if you look at the model, there is not a clear distinction between services, interfaces, and protocol, unlike the OSI reference model, right? For example, if I look at the internet layer, the only real service that is offered by an internet layer is sending an IP packet and receiving an IP packet. So I can really not figure out any difference between the services or the interfaces or the protocols used in the TCP/IP reference model. I can say that the protocols in the OSI model are hidden in a much better way than the TCP/IP reference model. And also, the protocols in an OSI reference model can be replaced easily, which is an important criteria, as and when required. Now, if I look at the OSI reference model, in case of the OSI reference model, the model came first and the protocols were designed later, right? So first came the model, that means, and then the protocols for that particular model were designed. So in that sense, I can say that this is a general model. That means it can fit in any protocol stack. It has no bias towards protocols because it was not specifically designed for any specific kind of protocols. It was designed first and then the protocols came. So that means in that sense it became general and it had no bias towards protocol. That is why I said that in case of an OSI reference model, it is easier to change the protocol stack. But what is the disadvantage then? The disadvantage is that since this model was a general model and was not designed for any specific protocol stack, so the designers had no idea of the subject and they did not know which functionality should be put in which specific layer, since it was a general model. So for example, if you look at the data link layer, originally it dealt only with point-to-point networks, but in a network you have both point-to-point networks and broadcast networks. So later, to deal with broadcast networks, a new layer had to be put in the OSI reference model. So in short, in case of the OSI reference model, if I cut long story short, I can say that things did not turn out the way they were meant to be. Now, moving on to the TCP/IP reference model, here it was just the opposite of the OSI reference model. In case of the TCP/IP reference model, the protocols came first and the model came later. So it is quite obvious that the model was designed specifically for the protocols. That means the model was according to the description of existing protocols. So that means quite clear that this was not a general model and it was protocol specific. And for this reason, the protocols could fit in the model perfectly because it was specifically designed for those protocols only. So the protocols had to fit in the model perfectly in that case. But the model did not fit in any other protocol stack also, right? Because since it was designed specifically for those protocols, it's quite obvious that it did not fit in any another protocol stack. So in this sense, the TCP/IP reference model was not flexible, and hence it was not suitable for non-TCP IP networks. Now, if I look at the layers of the OSI and the TCP IP reference model, I can clearly see that the OSI reference model has 7 layers, whereas the TCP IP reference model has 4 layers. Another big difference that an OSI reference model supports both connectionless and connection-oriented services in the network layer, but only connection oriented in the transport layer, because the transport layer is an end-to-end layer and this layer is visible to the users. So OSI chose to provide connection oriented services in the transport layer, which are more reliable than the connectionless services. Now, if I look at the TCP IP reference model, in case of the TCP IP reference model, it was just opposite. It supports the connectionless and connection-oriented services both in the transport layer, but only connectionless service in the network layer, right? Now, the advantage of having connectionless and connection-oriented services is that in the transport layer is that the users have a choice, especially when it is a request and response services. Request and response services are generally client server based services. So when it is a request and response services where the quality does not matter much, so the user has a choice to choose among the connectionless and connection oriented services, and generally in case of the request response services, a user usually prefers to have a connectionless service. So the advantage of providing a connectionless and both connection oriented services in the transport layer gave a choice to the users to choose among the two. So these are the differences between the TCP IP and the OSI reference model. So if I look at these two models after seeing the differences and after doing the comparison, I can say that in case of the OSI reference model, the model was of use, and in case of the in case of the TCP IP reference model, the protocols are more of use. So the OSI reference model, the network architecture, the model itself is of use, and the TCP IP reference model, the protocols are of use, and in networking, the protocols that are used are of the TCP IP reference model.